Thank you everyone for joining our session for the VSCode IDE Integration. Just a quick introduction, I'm Mohammed. To my left is Enguerrand, and to my right is Ziwei, and we also have Io, who is joining virtually to the conference. This is the core team working on the VSCode IDE Integration project. And just not to forget, we also have Ross Burton, who is overseeing our project. So just a quick shout out to him. So, who are we? We work as consultants at Savoir-Faire Linux. We like to specialize in open source technologies. We have a versatile experience in embedded language development, as well as web development and so on. So you will see a perspective from both web and the embedded side for this presentation. So it'd be a nice way to see that. To give you some context on what the project is and why we were mandated for this project was there was an RFQ, as I think most of you are aware of, by the Yocto Project community, and we were tasked to work on a previous existing fork by Eugene for the VSCode IDE integration. So we are not starting from scratch for this. Our goal is to maintain the application, to become maintainers and publish an official version of the VSCode IDE to the community. So some of the rationale for this project was to give a new encouragement to new users to use Yocto Project as part of their day-to-day activity. The tool of the VSCode IDE is a developing tool for these new users, as well as we would like to have, for more experienced users, a more versatile IDE support, which we'll see later down in the slides. So the goal is to have out-of-box features that are supported by VS Code, as well as we will look a bit later on some more experienced integrations with SDK and so on. So where are we with the project currently? For the past few months, we have taken over maintainership of the existing fork by Eugene, and we've published a maintained version, a stable version of the project to the marketplace. So we're happy to say that after the presentation, you can go ahead and download and play with the extension as of today. What's coming forward in the next few months? As I said, we are working on some advanced features that we will cover a bit later in the slides. And I think what we need from you is that go and use the extension and provide some feedback to us in our GitHub repository on the Yocto Project GitHub. So just to get over some of the operational slides, let's dig deeper into some of the design choices for the architecture, some of our challenges that we faced, and some of the libraries that we utilized.
So before we go into the really cool new features we added inside the VS Code, we wanted to briefly introduce what's happening behind the scene. So the extension is actually a TypeScript plugin that's based on the VS Code API. So as you might know, VS Code is basically an Electron browser with a specific API to bring things to the UI, for instance. So our extension is really integrated into that, and it's actually split into two different software. There is a client and a language server. So the extension client is the main entry point for the VS Code plugin. And some of the work is offloaded on the language server. So that will be presented to you. So we interact with VS Code, but also we directly interact with Bitbake. So if you were using the previous version from Eugene Wayans, it could be configured to do that and produce some new functionalities. Today you'll have a lot more functionality with that. We'll show that very soon. And we also now communicate with Bash and Python extensions because these languages are really tied in with Bitbake. So We of course we faced many challenges during development of this extension. One of the biggest one was that Yocto is a tool for embedded developers, and the extension has to be written in TypeScript. So there are very few Yocto developers who are also TypeScript experts. So that's really one of the areas where Savoir-Faire Linux as a company could really shine, because we combine teams who are experts in the web development and TypeScript, and also we have embedded engineers like myself. We also had many challenges while interfacing with the Bitbake language, because it's actually a quite complex language. So it's combined with Bash and Python as embedded languages. And also, Bitbake has a very complex include mechanism. So in order to know the context of the recipe, the .bb file you are seeing on your screen, it can include many other .conf or .inc files. And the logic behind that is so complex that we don't want to re-implement it. So we rely on Bitbake to give us the recipe context. But Bitbake parsing is also very slow. So we had to make clever use of Bitbake in order to call it, but not too frequently, so that we have all the features we want without having huge delays between UI updates. So I'll hand over to Ziwei.
So in order to provide intelligence in the extension for a language like Bitbake, which has complex language patterns, we need something that is good at handling it. So we chose to use a library called Trezor that help us to interpret the documents. Actually, Trezor itself doesn't interpret the documents directly. Instead, it generates a parser that can be used to parse documents for a specific language if the Trezor is configured for that language. So in our case, we need a Trezor for Bitbake, and then we can use this parser generator tool to generate the parser for Bitbake. And I put the GitHub repository link down below. You can check it out later. So now we have the parser. What does this parser give us? It actually parses documents into syntax trees. So on the left, you see the original documents in Bitbake, which I copied from the Poke. And on the right, you see the syntax tree, where everything on the left is represented as tree nodes. And every node has a node type, for example, required directive, and as well the positions at the original documents. And of course, this is only the representation of the tree. And in the code, you have access to a bunch of utility functions, which can be used to, for example, use the position to find the node, to find the parent node or sibling, etc. So with all these, everything else is made easy. So all we need is the position, and then we can use the position to find the node in the syntax tree. Let's say on the left, on the document on the left, I point my cursor somewhere in the last line, somewhere inside the curly braces, and then I would get the position from the VS Code, and again, I can use the position to search the syntax tree, and then I can immediately know that this node is a variable expansion syntax. Then I can move on and do what's next. For example, providing completion, go-to definition, etc. So basically, this is why we chose to use this library. It is easy to use, easy to maintain, and it's very good at handling complex patterns.
So the last part of architecture we wanted to discuss is testing. It was as an open source project, it's really important for us to have good testing so that we can quickly test contributions, for instance, and also ensure we don't have any regressions in the years or decades to come. So we really set up a state-of-the-art testing for a TypeScript project. We start with linter tests that ensure code quality. We also have unit tests. We use the Jest TypeScript testing framework. So it allows us to specifically test classes or functions implementations while mocking the rest of the libraries of the program. So for instance, we can mock the VS Code API. We also have grammar tests. Those are for syntax highlighting. So we are able to see if we have any regression in syntax highlighting. and we also want to test the full extension in its actual environment. So we developed integration tests for that. So they will actually run VS Code in a headless mode, run our extension inside that, and simulate some degree of user interaction and check that our extension provided good results. So these integration tests will go as far as calling Bitbake and testing that we correctly interface with it. And despite all of these tests, we still run in under 4 minutes. So that's really, really nice. Okay, so now we can go into the features.
Yeah. So I think since we take a look at a bit of the architecture and some of the challenges we faced developing and improving this extension, we'll spend this next slides into taking a look at how we improved syntax highlighting, hover go to definition, and also the integration with embedded languages.
As mentioned earlier, this extension was initially a fork of the one created by Eugene, and his version is already covering a lot of cases in terms of the highlighting. So we made some improvements. As you can see, this is what it looks like at the bottom. This is the screenshot of what it looks like with the extension. We have the highlights for variables like before, and the variable flags, strings, functions, and keywords. And just one thing to be noted, you will get the highlighting for Bitbake files for .bb and .bb append or .bb classes because they are unique to Bitbake. But for .conf and .inc, it is not the case because if you happen to install another extension that also affects these files, you might need to manually select the correct language mode for these files in order to get the correct highlighting. So we have made some improvements on the code completion. We have added the variables from Yocto and Bitbake, and these are coming from the documentations. We have added the overrides and the Bitbake operators, and they're from the documentations too. We have added the variable flags. And we have the custom variables and functions. These are very basic. And we have the Yocto tasks. And these are snippets, which will provide you an empty code block as shown on the image. We have added more keywords, and we have added the path completions. We now display the hover information for symbols, such as the Yocto variables, variable flags, and functions. As you can see, when you hover on the keyword homepage, it shows the definition from the documentation right above. And then we also have the hover definition for variable flags. Also, we have the definition for the tasks. As for the go-to definition, we have improved or we have re-implemented this feature using the tricitor, as we mentioned earlier. And the go-to definition for directives is working like before. And we're also working on the re-implementing the go-to definition for symbols, and they will be available in the next release. And this time is also implemented using the tricitor. And my colleague Io is going to explain the part for embedded languages.
Yes. So let's first take a moment to see what we call embedded languages. Embedded languages are languages that are embedded into another. It has nothing to do with embedded systems. One common example could be CSS and JavaScript that can be embedded into HTML. In our case, Python and Bash are embedded into the Bitbake language. So in the first block, we see inline Python. In the second block, there's a Python function, and in the third one, a Bash function. We aim to offer to the Bitbake user an experience as good as when they type a normal Python in a normal Python file, a normal Bash into a normal Bash file. We achieve this with what we call the request forwarding approach. So VSCode already has a lot of extensions supporting Bash and Python, and it will not be realistic to open link Bash and Python as good as these extensions that are pretty used by hundreds of thousands of people. VSCode gives the possibility to call this extension and use their result. This is what we call request forwarding. Our extension is in theory, our extension is compatible with any extension that the user chooses to install, but we cannot test our extension with all the extension there is. So we select only two, the Bash IDE by Mads Hartmann and the Python extension made by Microsoft. Since these two seem to be quite standard, and we even add them as dependencies to our extension. So when you install our extension, these will be installed if it is not already done. Now we will see some functionality that we have implemented. So here we have code completion. When the user type something, it will propose it will propose some code, and it is just not to share. So we can send it to functionality. Here we show the description of a function when the user puts their cursor on it. Here we can just notice that the cursor is over a Bitbake module. So we add the Bitbake to the Python path, and it will show the definition of the function of the Bitbake function. We also add support for diagnostic. In the VSCode terminology, diagnostic are a error or a warning for a file. So on the second line, you can see a variable that is not used. On the third one, a variable that is that does not exist, and then just indentation error. It is the same error you'll see on a normal Python file. So request forwarding is not as straightforward as just calling author extension. It requires some additional work, and it is for that reason that we don't yet support all the functionality that you will see on the author extension. And we thought you might be interested to see a bit how it works in the background. So here on the left, we have the original document that we showed since the beginning. And that document cannot be interpreted by the Bash or Python extensions, since they don't know Bitbake. So instead, what we do is that we create in the background another file. Here we have a Python document that convert the file in a Python file, and also add some imports, so it can use and give the result we want. And there's also some challenge with the position that change, and also managing these documents efficiently. So now my colleague Enguerrand will talk about the SDK integration.
So for calling the SDK, we first want to have a terminal-free Bitbake experience inside VS Code with our plugin. So we had to first implement a way to really bring Bitbake builds inside the UI. So first, you'll have to configure how Bitbake is run. So we show here the setting, one example of a settings.json that provides all the configurations we need to run Bitbake inside its environment. So this configuration is inherited from Eugene Wyance's version. So basically, we need to know the path to the environment script, where the build folder will be located, and also where Bitbake is located. So you'll need to configure some of these settings for if you want all the features we presented during the previous slides to work. And then we also can run Bitbake builds from VS Code now. So you don't need to bring out your terminal and do that yourself. So there is an example task.json that shows what kind of builds we can run. So here we run Bitbake core image minimal. So you have a Bitbake type for tasks, and then you select the recipes you want to build, and whether you want to run just the build task or you can run any kind of task. We can also parse Bitbake recipes. So yeah, next slide. So we want to call Bitbake, but most users will have can have very complex environments and not just sourcing OE init build env script. So many developers actually run VS Code on their laptop, but they will run all the Yocto builds on a more powerful server, which they connect to through SSH. So we support that use case. You can actually combine our extension with the remote SSH environment extension that is an official VS Code plugin. And so you'll see the files on your build server, and all the Bitbake builds and commands you'll run from your UI on your laptop will be run on your server. Next up, for the next releases, we'll also want to support wrapper tools to call Bitbake, namely a few examples could be CAS, Poky, Crops, Docker containers, or also CQFD. So we'll be adding support for them in the next releases, so that you can call Bitbake in probably all the ways you want. So to bring the Bitbake builds, you can either use the tasks.json as I showed a few slides back, but we also added a contextual menu. So that's presented on the right here. So from VS Code, you can right-click anywhere on the VS Code on a Bitbake file, and you have a few contextual commands that allow you to quickly build the recipe you are viewing, to clean it, or to run any specific task. On the left, we also added a navigation panel, so you can add a few recipes you are interested in inside that panel, and it will show you all the related included files and bb append in the context of your project for that recipe, and you can also quickly build, clean, or run any specific task as well from there. So now with that, we are able to run Bitbake inside VS Code. We can also get the errors that it generates. So similar to the diagnostics EO showed you on embedded Python and Bash, we can get the errors from Bitbake, mostly parsing errors, and show them in the diagnostics view. So they are all linked to the specific line that failed to parse. You have the error message. And if you're really into new tech, you can even use the quick fix using Copilot. So maybe he'll make something that works, maybe not, but that's a feature. We also check the sanity of the settings you provide in the settings.json. So if you call Bitbake through a manner we haven't implemented yet, so give us a feedback, but you may want to disable running Bitbake and parsing the recipes every time you save a document. So we added a feature that allows you to quickly get notified if we can't run Bitbake through your environment, and you can disable those features for the time being. So because we'll be calling Bitbake and it's a bit slow, and Bitbake doesn't allow concurrent calls to its Bitbake server, we wanted to report that we are actually running Bitbake or not. So that's done through an activity status that is displayed at the very bottom of the VS Code IDE. And you'll see if we are calling Bitbake, building, or if we are just idle, and you may run Bitbake from the terminal if you want as well. So all of this is to provide a terminal-free experience for Yocto users to build their images and recipes, but also to provide a terminal-free way to use Bitbake for application developers. So we are really excited by Adrian's work that he presented just the presentation before. And so we want in the next releases to integrate that inside our plugin. So application developers and even Yocto developers can quickly patch or develop applications using VS Code without where the calls to Bitbake are hidden, so that it's way faster and closer to what application developers are used to when they develop applications. So to give a brief idea on how that will work, we will add new features to the Bitbake view panel. Mainly, you will be able to manage DevTool workspaces through there, so you can automatically run DevTool modify on the recipes you are interested in modifying. And then we'll call the DevTool IDE SDK from Adrian, and that will generate you a working VS Code workspace for cross-compiling and debugging, and that will all be very seamless. And then you can go back to your Bitbake workspace and run DevTool finish, for instance. So it's really about integrating the DevTool IDE SDK features.
So just to summarize all of the work we've been working for the past few months, we highly encourage the community, you guys, to go and download the extension, give us your feedback, and we're definitely open for contributions from the community as well. So the more feedback we get, the more we can solidify the extension. And yes, thank you for your time.